And now in this lecture we'll find out the area of a circle. In the drawing we have a circle and we have also square ABCD. This is square ABCD. We know that this is line segment AP, that is equals to 1 unit in its length. This is line segment CQ, that is equals to 3 units in its length. Again, our mission is to find out the area of this circle. So first of all, we define the center of this circle. This point is point O. And we will define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we will focus at this point, point B. From this point, point B, we have two tangents to this circle, tangent BQ and tangent BS. So here we can implement rule 2. So I put quickly on rule 2. According to rule 2, the lengths of two tangents from a common external point to a circle are equal. So in the drawing we have a circle and we have also, this is the common external point, point P. From this common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Why? Because in our drawing, if we focus on this common external point, point B, from this common external point, point B, we have two tangents to this circle, tangent BQ and tangent BS. And according to rule 2, they are equal to each other. That is to say, BQ equals to BS according to rule 2. So I write it down. BQ, tangent BQ equals to tangent BS according to rule 2. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other in their lengths. We know that all the angles inside the square are right angles. So those four angles, they are all right angles. So I write it down. This is a right angle. This is also a right angle. This is a right angle. And finally, this is also a right angle. And we also know that all the sides in any square are equal to each other. That is to say, side AB equals to side BC in this square ABCD. So I write it down. In square ABCD, side AB equals to side BC. So this is equation 1. Side AB equals to side BC in square ABCD. AB in total equals to AS plus SB. Again, AB in total equals to AS plus SB. So AB equals to AS plus SB. And AB equals to BC. BC in total equals to SQ plus QC. So I write it down. Again, BC in total equals to BQ plus QC. BC equals to BQ plus QC. According to equation 1, we actually found out that AS plus SB equals to BQ plus QC. So here we have AS is the missing side, so we leave it as it is. AS plus SB. SB equals to X. So we substitute SB, again SB equals to X. So we substitute SB by X. And it is equals to BQ. BQ also equals to X. So we substitute BQ by X. Plus QC. QC equals to 3 units in itself, according to what is given in the question. So we substitute QC in this equation 1 by 3. So in total, according to equation 1, AS plus X equals to X plus 3. Here we subtract X from this equation 1. And finally get that according to this equation 1, AS equals to 3 units in its length. So if we found out that AS equals to 3 units in its length, so I write it down. AS equals to 3 units in its length. If we focus on this point A, from point A, we have tangent AS to the circle. Tangent AS is tangent to the circle point S. And we also have here line segment PD. So we'll extend side AD of square ABCD by a straight line until it touches the circle. And we'll define the touching point of the extended side AD with this circle. This point is point M. So from the common example point A, we have chord PM. Chord PM is chord in this circle, and from the same common example point A, we have chord A. We have tangent AS. So actually, all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. So I'll repeat quickly on rule 10. According to rule 10 is true in any circle. So in any circle, if AB is any chord, here AB is chord of this in this circle. So AB is a chord in the circle, and PT is a tangent to the circle. PT is tangent to the circle at point T, and AB is a chord in the circle. So if this is the data that has been given to us, then the following equation will be true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. So we can definitely implement rule 10 in our drawing. Why? Because in our drawing, as I already mentioned before, from this common example point A, we have tangent AS, that is tangent to this circle at point S, and we have also chord PM from the same common example point A. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that AS square equals to AP times AM. So repeat again, according to rule 10, if we focus at point A, if we focus on the common example point A, according to rule 10, the following equation will be true. That AS square equals to AP times AM. Again, according to rule 10, if we focus on the current standpoint, point A, the following expression will be true, that AS squared equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9. And it is equals to AP times AM. AP equals to 1, according to what is given in the question, times AM. AM in total equals to AP plus PM. Repeat again, AM in total equals to AP plus PM. So in total we found out that 9 equals to 1 times AP plus PM. So 9 equals to 1 times AP plus PM, of course, equals to AP plus PM. So in total we found out that according to rule 10, 9 equals to AP. AP is 1 plus PM. So 9 equals to 1 plus PM. Here we subtract 1 from this equation, and you get that PM equals to 9 plus 1, that is 8. So if you found out that chord PM, that is the chord in this circle, is equal to 8 units in its length. PM equals to 8 units in its length. In the next step, we'll do a construction. That is to say, from this point O, that is the center of the circle, we will draw perpendicular on AM. Again, we will draw from point O, we will draw perpendicular on AM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AM. This point is point N. So actually, from the center of the circle, that is to say from point O, we have perpendicular ON on chord PM. Again, from point O, because the perpendicular on AM is also perpendicular on PM, because AM is one straight line. So from point O, that is the center of the circle, we have perpendicular ON on chord PM. And therefore, all the requirements of rule 11 are satisfied, and therefore we can implement here rule 11. So I'll think quickly on rule 11. According to rule 11, the perpendicular of a chord drawn from the center of the circle bisect the chord. So in the drawing we have a circle, and point O is the center of this circle. From this point O, that is the center of this circle, we have perpendicular OM on chord AB. Again, from the center of the circle, that is to say from point O, we have perpendicular OM on chord AB. And according to this rule, rule 11, the perpendicular OM on chord AB also bisects chord AB. That is to say, it divides chord AB into two halves. That is to say, AM equals to MB. So according to rule 11, whenever you draw a perpendicular from the center of the circle towards any chord, the perpendicular also bisects the chord. In this case, perpendicular OM bisects chord AB. That is to say, AM equals to MB. You can definitely implement rule 11 in our drawing. Why? Because in our drawing, we have perpendicular ON that is drawn from the center of the circle, that is to say from point O. And according to rule 11, whenever you draw a perpendicular from the center of the circle, that perpendicular also bisects chord PM. Okay, so according to rule 11, perpendicular ON bisects chord PM. Okay, that is to say, it divides chord PM into two halves. The first half is PN and the second half is PM. So according to rule 11, PN equals to NM equals to PM over 2. Each half of the chord is equals to PM over 2 because the length of PM, the length of the chord is PM, and therefore half of PM is of course PM over 2. So each half is equals to PM over 2. The first half is PN, this is equals to PM over 2, and the second half is NM, that is also equals to PM over 2. We have already found out that PM equals to 8, therefore PM over 2 is 8 over 2, that is 4. So PM equals to 8 over 2, that is 4. So in total, we found out that Pn equals to 4. So this is line segment Pn that is equals to 4 units in its length according to rule 11. Pn equals to 4. Therefore in total An equals to AP plus Pn. That is to say An in total equals to AP, that is 1, plus Pn, that is 4. 1 plus 4 is 5. So An in total equals to 5 units in its length. In the next step, we join points O and S together by straight line. Point S is the point of tendency of tangent AB with this circle. Point O is the center of the circle. Point S is the point on the circle itself. So this is exactly the definition of a radius. Therefore OS is the radius of this circle. We define the radius of this circle as x. Again, x is the radius of the circle. So OS equals to x, and x is the radius of the circle. So here actually can implement rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have also this is tangent AB, that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have the radius OM that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. According to this rule, rule 1. So we can actually implement rule 1 in our drawing. When put in our drawing, we have the radius OS that equals to x, the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So by doing this construction, we can do quadrilateral ANOS. Inside quadrilateral ANOS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral ANOS as a rectangle because it has 4 right angles. So I'll write it down. So this quadrilateral ANOS is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN equals to the opposite side OS. But and AN in total equals to 4 plus 1, that is 5. Therefore OS must be also equal to 5 units in its length. That is to say, we should find out that OS that is equals to X, and X is the radius of the circle, is equal to 5 units in its length. So in total we should find out that the radius of the circle, X equals to 5 units in its length. Our mission is to find out the area of the circle. And the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle equals to pi times the radius of the circle squared. And therefore, the area of this circle must be equal to pi times the radius of this circle squared. The radius of this circle is x, the radius squared is x squared. So in total, the area of our circle must be equal to pi x squared. X is 5, so in total, the area of our circle must be equal to pi times 5 squared, that is 25. So in total, we should find out that the area that we are looking for in this question, that is the area of this circle, equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So repeat again, we found out that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. Okay, so in the next step, also in the lecture. In this lecture, our mission is to find out the area of this circle. So in the drawing, we have a circle, and we have also square ABCD. This is square ABCD. In addition, we know that this is line segment AP, that is equals to 1 unit in its length. This is line segment QC, that is equals to 3 units in its length. Again, our mission is to find out the area of this circle. So, first of all, we know that all the angles inside the square are right angles. So, those 4 angles are all right angles because they are located inside square ABCD. So if we focus on this common external point, point B, from this common external point, point B, we have 2 tangents to this circle, tangent BQ and tangent BS. And according to rule 2, they are equal to each other. That is to say, BQ equals to BS according to rule 2. Repeat again, according to rule 2, the length of tangent BQ is equal to the length of tangent BS. Okay? So if we define the length of tangent BS as x, then the length of tangent the length of this tangent BQ must be also equal to x because they are equal to each other according to rule 2. In addition, we know that all the sides in any square are equal to each other. That is to say, AB equals to BC equals to CD equals to DA. So we know that AB equals to BC. Okay, square ABCD, side AB equals to side BC. I'm beginning again. Square ABCD, side AB equals to side BC. AB in total equals to AS plus SB. Again, AB in total equals to AS plus SB. So we substitute AB by AS plus SB. And BC in total equals to BQ plus QC. Again, BC in total equals to BQ plus QC. So we substitute BC by BQ plus QC. So in total we found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB is X, so substitute SB by X. And it is equals to BQ. BQ is also X, therefore we substitute BQ by X plus QC. QC equals to 3, so we substitute QC by 3. So in total we found out that AS plus X equals to X plus 3. Here we subtract X from this equation and equation 1. We found out that according to this equation and equation 1, so X will get cancelled. AS equals to 3. So we found out that the missing line segment AS is equal to 3 units in its length. So if we focus on this common extent point A is also the vertex of square ABCD also, but A is also common extent point in relation to the circle. So from this common extent point A, we have tangent AS that is tangent to this circle, point S. In addition, from the same common extent point A, we have here line segment PD. So actually extended line segment AD, or we have also line segment AD. So from the common extent point A, we have line segment AD. So actually extended line segment AD by straight line until it touches the circle, and we define the touching point of the extended line segment AD with this circle. This point is point M. So in total we can say that from the common standpoint point A, we have tangent AS that is tangent to this circle, this point S, and in addition, from the same common standpoint point A, we have also chord PM. Again, from the same common standpoint point A, we have tangent AS, and we have also chord PM that is called a chord inside this circle. So actually all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. So I can quickly on rule 10. According to rule 10, rule 10 is true in any circle. So in any circle, if AB is any chord in the circle, AB is the chord inside the circle, and PT is a tangent to this circle at point T. So in this drawing, from the same common standpoint point A, we have here chord AB, and we have also tangent PT that is tangent to this circle at point T. So in this drawing, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. So we can actually definitely implement rule 10 in our drawing. In our drawing, if we focus on this common standpoint point A, on this common standpoint point A, we have tangent AS that is tangent to this circle point S. In addition, from the same common standpoint point A, we have here chord PM that is a chord inside the circle of the circle. So all the requirements of rule 10 are satisfied, and therefore according to rule 10, the following equation will be true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. So if we focus on the common standpoint point A, according to rule 10, we get that AS square equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9, and it is equal to AP. AP is 1 according to what is given us the question. So we substitute AP by 1 times AM. AM in total equals to AP plus PM. Again, AM in total equals to AP plus PM. So substitute AM by AP plus PM. So in total we found out that 9 equals to 1 times AP plus PM. 1 times any number is equals to the same number itself, so 9 equals to AP plus PM. The multiplication by 1 will not change the value of the expression. So in total 9 equals to AP plus PM. So 9 equals to AP. AP is 1. AP is 1 plus PM. So in total, we found out that 9 equals to 1 plus PM. Here we subtracted 1 from this equation, and finally found out that PM equals to 9 minus 1 is 8. So we found out that this is called PM, and it is equals to 8 units in its length. Okay. Now we did a construction, that is to say, point O is the center of the circle. From point O, we draw perpendicular on chord PM. Again, from point O, we draw perpendicular on chord PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and PM. This point is point N. Okay. So from the center of the circle, that is to say from point O, we have perpendicular ON on chord PM. So all the requirements of rule 11 are satisfied. Therefore, we can implement here rule 11. According to rule 11, the perpendicular to a chord drawn from the center of a circle bisect the chord. So in the drawing we have a circle, point O is the center of the circle. So from the center of the circle, that is to say from this point, point O, we have perpendicular OM on chord AB. And according to this rule, rule 11, perpendicular OM bisects chord AB. That is to say AM equals to MB. So we can actually implement rule 11 in our drawing. One put in our drawing, from the center of the circle, that is to say from point O, we have perpendicular ON on chord PM. Again, from point O, that is the center of the circle, we have perpendicular ON on chord PM. And therefore, according to rule 11, perpendicular ON bisects chord PM. That is to say, divide chord PM into two halves. The first half is PN, and the second half is PM. So, PN equals to NM equals to PM over 2. According to rule 11, of course. Again, the first half is PN, and it is equals to the second half, that is MN. And in one half of PM is PM over 2, of course. Each half equals to PM over 2. So PM over 2 equals to MN equals to PN. But we have only found out that PM equals to 8. So PM over 2 is 8 over 2, that is 4. So in total we found out that according to rule 11, PN equals to MN equals to 4. And especially PN equals to 4 units in its length. This is line segment PN that equals to 4 units in its length according to rule 11. From the center of the circle, that is to say point O, we join points O and S together by straight line. Point O is the center of the circle, point S is the point of the circle itself. point S is the point of tendency of tangent AB with this circle. So this is exactly the definition of a radius. Therefore, OS is the radius of this circle. We define the radius of this circle as x. Therefore, OS equals to x units in itself according to our definition. Here we have the radius OS that is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So actually, inside quadrilateral ANOS, this quadrilateral ANOS, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to our construction. This angle equals to 90 degrees according to rule 1. And this angle equals to 90 degrees because ABCD is a square. And all the angles inside the square are right angles. So in total, inside quadrilateral OSAN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral OSAN, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle, if not a square. So we will relate to quadrilateral ONAS as a rectangle because it has 4 right angles. So in rectangle ANOS, the opposite sides are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 4 plus 1, that is 5. Therefore, OS must be also equal to 5 units in its length. But OS is x. That is the radius of the circle. That is to say, the radius of the circle, x equals to 5 units in its length. So in total, we found out that the radius of the circle is equal to 5 units. And we know that the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, the area of our circle equals to pi x squared. And x is 5, therefore x squared is 5 squared, that is 25. So in total, we found out the area that we are looking for in this question, that is the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. Okay, thank you very much.